आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone. So the question is, if L is equals to limit n approaches to infinity 2 into 3 square into 2 cube into 3 raised to the power 4, and this multiplication goes up to 2 raised to the power n minus 1 into 3 raised to the power n whole raised to the power 1 upon n square plus 1. Then the value for L raised to the power 4 is, we're having 4 options. We have to calculate the answer and then take which of the following option is the correct option. Firstly, I'm writing down the value of limit, that is L, limit n approaches to infinity 2 into 3 square into 2 cube into 3 raised to the power 4, and this goes up to, last two terms are 2 raised to the power n minus 1 into 3 raised to the power n and whole raised to the power 1 upon n square plus 1. Now, fully observing at this limit, you can say that it is 2 raised to the power 1. So you can see that the alternate terms are 2 raised to the power something, and the other terms are 3 raised to the power something. Also, we can see that all the powers of 2 are odd and all the powers of 3 are even. So we can separate it. So it would be equal to limit n approaches to infinity 2 raised to the power 1 into 2 raised to the power 3 into 2 raised to the power 5, and this goes up to 2 raised to the power n minus 1. Similarly, this is 3 raised to the powers 2 into 3 raised to the power 4, and this goes up to 3 raised to the power n. Here also it is okay, I'm writing it combined here, 1 upon n square plus 1. Now we know the sum of, there's one more step, the base are same, so we can add the powers. So that is 2 raised to the power 1 plus 3 plus 5 up to, you can see the total number of terms are n. So what is the terms which is 2 raised to the power something is having? It is surely n by 2 into 3 raised to the power 2 plus 4 plus 6 up to n by 2 whole raised to the power 1 upon n square plus 1. Now we know that the sum, that is 1 plus 3 plus 5 up to n by 2, what is the sum of these terms? This is limit n approaches to infinity. This is nothing but this is 2 raised to the power. Generally, it is n square by 2, but since the terms are n by 2, so it is n square upon 4. Similarly, it is now generally what is the sum of the sum of terms which is having first term as 2 and common difference is also 2, so that is n into n plus 2. So basically, what is the sum of these terms? This would be n into n plus 2 upon 4. Correct? Now, proceeding forward, what I can say, I can write it as 2 limit n approaches to infinity 1 upon, okay, this is 1 upon n square plus 1 also. So if I'm combining the powers, it would be 2 raised to the power limit n approaches to infinity. I'm taking n square common from both numerator and denominator. So it would be n square upon 4 also I'm taking common. So that would be 1 upon 1 plus 1 upon n square. There also have taken n square common. So this will be cancelled out and we are left with this only. Similarly, it is 3 raised to the power limit n approaches to infinity. I'm again taking n square common. So it will be n square into 1 plus 2 upon n square into 1 plus 1 upon n square. So now what I get? 2 limit n approaches to infinity 1 upon 4, 1 plus 1 upon n square into 3 raised to the power limit n approaches to infinity 1 plus 2 upon n upon 1 plus 1 upon n square. Now let's apply the limit. So if I'll be applying the limit n approaches to infinity, I get 2 raised to the power 1 upon 4 into 3 raised to the power 1 upon 4. If the powers are same, I can multiply the base. So that would be 6 raised to the power 1 upon 4. This is the value of L. Now I have to find L raised to the power 4. So that would be 6 raised to the power 1 upon 4 into 4. So it is 6. So the answer is 6. Let's see which of the option is correct. So we can see it is not in among first three. So it is none of the above. So therefore option D is the correct option. I hope this is clear. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।